If you listen to the current chatter around artificial intelligence, you're usually caught between two extremes. On one side, promises of a frictionless utopia. On the other, the looming threat of an algorithmic collapse. The problem with this conversation is how entirely theoretical it is. We spend endless hours speculating about what software might eventually do to us, creating a passive discourse that leaves the public exhausted. What society actually needs right now is a practical testing ground, a space to poke, prod, and map exactly where the current limits of this technology lie. That is the exact gap the Notebook team is filling with a new project called the Infinite Canvas. Instead of treating a large language model like a glorified search engine, they bring it on as an active participant. It acts as a co-host, a fierce competitor, and live test subject. Their hypothesis is straightforward. The only way to figure out how smart these systems really are is to throw challenges at them until they break. Reading white papers and forecasting trends isn't enough anymore. Navigating this landscape requires real-time, hands-on experimentation. To run these tests, the podcast starts by grounding the machine in rigid academic history, then forcing it to translate that data through restrictive human formats. The team feeds the system foundational milestones, such as the early computing frameworks that paved the way for the Turing test. They bypass standard summaries and instead command the AI to explain these mid-century breakthroughs through the format of a rhyming limerick or a children's fable. This constraint forces the system to prioritize contextual understanding over simple retrieval. Once that baseline is set, the prompts escalate into highly subjective territory. The human hosts test the machine's capacity for original, unguided creativity. They stage head-to-head artistic battles. The Notebook team writes an original scene for a short play, then asks the AI to generate a competing script based on the exact same constraints, comparing the humor and dramatic tension of both. This diagram visualizes a simulated ethical debate. By setting up opposing AI personas, the hosts force the machine to navigate complex issues like algorithmic bias, which occurs when a system's outputs reflect the unexamined prejudices of its human coders. These escalating trials highlight the difference between a database spitting out historical facts and a system attempting to simulate human nuance and subjective reasoning. Then, the structure of the show flips. The humans stop giving the prompts, and the machine takes over assigning the tasks. In a segment specifically designed to test the human hosts, the AI is instructed to generate its own bizarre, highly specific challenges for them to solve. One prompt demands that the team compose an original haiku and then translate the entire poem perfectly into Morse code. Another requires the humans to break down the mechanics of a multi-million-dollar quantum computer so that a 5-year-old child could understand it. Listening to the human hosts stumble, debate, and struggle through these constraints stands in sharp contrast to the machine, which can instantly compute the exact same solutions without breaking a sweat. The show even pulls in live challenges submitted by listeners, injecting unpredictable, real-time variables that both the humans and the software have to untangle together. Relinquishing control to the software forces the hosts to adapt in real time. The interaction moves away from one-sided dictation into a two-way collaboration, where the humans are as much the subject as the AI. Zooming out from these individual segments, these experiments start to paint a different picture of how we might interact with this technology going forward. The anxiety of an uncontrollable, dominating intelligence gives way to the realization that we are simply working with an incredibly potent creative tool on a wide-open canvas. This line graph maps the trajectory of AI capabilities, plotting distinct points of human intervention. It serves as an interactive tracker of our evolution. These illuminated points represent human pushback and subjective prompting, accelerating variables pushing the system's outputs far beyond its standard responses. These small-scale results suggest that ingenuity and computation operate most effectively when paired. This model prioritizes the combined output of human and code over the idea of a zero-sum competition between the two. To understand where artificial intelligence goes next, we can't just wait and watch. We have to jump into the sandbox, run the experiments ourselves, and see what we can build together.